Behind me, I'd like to show you a cell that we used IMTS to help design. Our customer approached us with a part that traditionally is sent to a low-cost country. It's a very high-volume part, relatively low-margin part that our customer really wanted to keep domestically. We wanted to help them very badly. We thought it was a big opportunity for us and also an opportunity for the customer. We went to IMTS to find a solution, to figure out how we can make this the highest quality that we possibly could, yet still be competitive in America. We ended up getting 2 Akuma, 2 SPCNC lathes, an M460 vertical machining center, and 4 FANUC robots, and put together a cell that produces this literally from start to finish to packaging by itself. Now, obviously, we need operators, but we wanted to take care of all of the mundane, the routine, and especially the carpal tunnel-like processes within this. We needed to automate that, and we needed to make that efficient. So what we came up with is something we're very, very proud of. An often misunderstood aspect of robots is people think that they're always complex, and it takes a lot to install them. These robots are really quite simple in what they do. What we had as a goal for these is to just basically have the highest level of machine uptime we could. The robot's job in these applications is to do nothing but load the machine and unload the machine. By doing that, we realize a 90 to 95% uptime on the machine in terms of overall realized efficiency.
We actually have 4 shop floor CMMs because every operator here is responsible for their own part quality. It's something we feel is very important to make sure that the operators understand the whole process and are responsible for what they're doing. Another positive thing about our CMMs is they're connected to the enterprise system. So our QA department is able to see what's going on real time if they need to. We're merging all the data together so we know what's going on at the machine, who the operator is, who's inspecting the part. That's all tied together. Makes it really easy to manage our quality system when everything's tied together in enterprise like we have it set up. We track every single thing within this company. We feel it's really important to have a strong traceability of our customers' parts as they travel through the shop. That process actually starts right here with this barcode tag. Every bundle, every box, any type of container that comes in the door gets tagged. And from that point forward, that part in raw form all the way to the finished part is being tracked. Every cart, every rack, every machine, every inspection point that's being done is being recorded. And at the end of the day, we can take a packing list that's shipped to a customer. With that information, I can tell you who did what, on what day, at what machine, at what location, on every single part that we're running through the shop. So back in 2002, we actually started looking into machine monitoring. And as we integrated that in, at the time, all we had was vertical machining centers. We found out really quickly that vertical machining centers are not very efficient. So that led to what you see here today, which is a bank of 6 400mm horizontals. These machines are far more efficient. On a good day with a good operator, you can maybe get in the 60% range with a vertical. On a horizontal, you can run in the 90s while you're sleeping. It's phenomenal how much better they are with the efficiencies.
Tool life management is something that is very, very important to us, and it's often overlooked. In order to have process control, you need to understand the life of your cutting tools. You need to understand when those cutting tools are being changed. And most importantly, you need a process that is stable. So the red light you see up here, in this instance, is not saying the machine is broke or something's bad. What it's saying is the fact our cutting tool is expired. It tells the operator right now that this tool is on its last cycle. So this machine will not restart when the next fixture is ready. Instead, it's going to literally stop and make sure, if the operator has not done it already, a new cutting tool is put in place of this worn-out cutting tool. The only way you can have process control is truly understanding and making sure that your cutting tools perform consistently. For everybody without a centralized coolant distribution system, you know machine tools go through a lot of coolant. I mean, they go through a lot of liquid, and you spend a lot of time moving that liquid. We came up with a distribution system that distributes water to all the different machines, so the operators can use refractometers, making sure that the coolant concentration level is correct on each shift. It does a lot of the work so the operators don't have to spend all that time taking hoses around the shop and just hauling water. It's just one more way that we took a non-value added activity and tried to make it more efficient.
When we set up a new job and we have one of our engineers come up with tooling for it, when they enter that tooling into the system, it automatically shows up on the presetter. When we create setup sheets, it automatically shows up on the presetter. So we're communicating information digitally back and forth between devices without having to retype anything in. So our tool crib attendant has everything they need to do their job, so they can come in here, gather up the tools, go to our tool boss, take the tooling out, put everything together, preset it here, put the tags on it, get it on the cart, and take it out to the machine to get set up.
Heat shrink tooling is becoming more popular as time goes on. We use heat shrink tooling for several different applications. One thing we found with heat shrink that really helps is the reduced number of components. You know, with a heat shrink holder, you only have one object, aka the holder itself. You know, a lot of times nuts, collets, all of that get damaged, get lost, etc. Heat shrink really simplifies that by just having one component. You know, it's very, very important to make sure the heat shrink holder is ultra clean. I mean, cleanliness is next to godliness when it comes to heat shrink. But if you pay attention to that, you're going to have excellent balance, you're also going to have excellent repeatability, and you're going to have excellent runouts, concentricities, etc. on your cutting tools. At Metalquest, we employ some variable-based programming, and we do it because we feel it's a better application and it's a better tool for the job that we're trying to do. Take this part, for instance, right here. This part is part of a family. We have a lot of different overall types of this part, but they have very similar feature sets. So we've got a series of variables that we program based directly off the print. By inputting print data, the machine tool literally does the math to figure out what this part needs to be when it's all said and done. The right cutters, the right tools go in and machine it and turn it into what it is. The advantage of that is when you have a lot of different parts that you're making, you only have to keep track of one program at that point. It's the benefits of having a high-performance program anytime you need it, spread over many different types of parts.
If we didn't come to IMTS, I mean, I would literally be lost. It's a learning experience that you absolutely must have. Otherwise, you are going to start becoming irrelevant in this industry, because this is where you learn everything that's important to this industry.